Guys. So I'm going to look today at how we sketch cubic functions. So if you read the slide before this, you will have seen that I said, often in quadratics we started with a standard form and we factorized it to get it into factored form, and that helped us find the roots. We could then also find the y-intercept and find the turning point. We're going to focus on cubic functions, so functions that have x to the power 3. And we're going to look at what we can find quite easily. So provided we can get it into factored form, we can really easily find the roots, just the same as we did with quadratics. And we can easily find the y-intercept by substituting x as 0. And then I'll show you what happens then, like how do we determine where turning points are or what the shape of the graph is. This is an introduction question, okay, so it doesn't have all of the information, but it will get us started on what we need to think about. So with this question, we're being asked to sketch the graph of the polynomial or the cubic function x times x plus 5 times x plus 1. Now this function is already in factored form, so we don't have to do we don't have to use the factor theorem, we don't have to do polynomial division. It's already done for us, okay? So what we want to do is make this equal to 0, okay? So we're going to, because we know that the roots happen where y, or the polynomial, the vertical axis, equals 0. So 0 equals x times x plus 5 times x plus 1. Now we know, using our null factor law, that if 0 equals something multiplied by something multiplied by something, so the product of factors, that each individual thing must equal 0. So this first thing, x must equal 0. Well, that was easy work. 0 must equal x plus 5. So rearranging that, we get x equals negative 5. And 0 must equal x plus 1. Rearranging that must make x equals negative 1. So what we've got there, we've got our 3 roots. Okay, so we found our 3 roots. The next thing I said that's helpful is to find the y-intercept. So we find the y-intercept when x equals 0. X equals 0. So the polynomial x, now we're going to substitute 0 into all those places. 0, 0 plus 5, 0 plus 1. Now we've got 0 times other things, so it kind of doesn't matter what the other things are. This whole thing is going to become 0. Okay, so my my y-intercept is actually happening at the origin. Now in terms of turning points and things, I am going to discuss that a little bit more later on, but we're going to get a sense of what this graph looks like. So I'll draw up some axes just quickly. So here is my x. Sorry, I probably need a little bit more on that direction. I don't think that through very well. Here is my x. Here is my y, or my p of x. Because it started with p of x, I'm going to keep it as p of x. Okay. So what I know is that I have a root at x equals 0. I have a root at x equals negative 5. And I have a root at x equals negative 1. I also know my y-intercept is here. So the thing I don't know is which way my graph goes. Okay, so cubics have 2 bumps. You know, we've talked about this before. So either my graph goes like this, something along those lines, okay, or my graph has those same intercepts, so negative 5, negative 1, and 0, but it goes the opposite direction. So it goes something like this. Sorry, that didn't quite go through. Yeah, I'll do a little cheat. So it goes this way. Now I have to decide which way it goes. And the way I do that is by looking at the coefficient of the leading term. Okay, so basically the coefficient of x cubed. Now, this is in factored form, so it's a little harder to see. But what I can see is that if I were to expand these things out, I've got a positive x and a positive x and a positive x. So at some point when I multiply them together, I'm going to get a positive x cubed. Okay, and it's going to be monic. It's going to be, because it's 1 times 1 times 1. So it's going to be positive, or just 1x cubed. Now, if it's a positive cubic, what that means is it starts down the bottom, and as we move left to right, it goes up, just like a positive gradient with a linear equation. Okay, so that means that this one must be correct, because I start down here on the left and eventually I get up on the right by the end of the graph. This one wouldn't work because here I start on the left, but eventually it goes down. So that one has like a negative gradient, if you were to think of it in terms of linear function. So it must look something like this version, okay? For now, that's as much as you need to sketch. I'm not concerned about the bumps and those points at this particular moment in time. We will get there, but it's not urgent at this point.